All right, let's get into it. Today we're going to tackle, well, the biggest story there is. We're talking about the complete history of our universe, from a beginning so small it's hard to even imagine, all the way to its wild, mind-bending, ultimate fate.
Yeah, we're covering everything.
It's probably the most fundamental question we've ever asked ourselves, right? Where does all this everything come from? It's the kind of question that's kept people up at night for thousands of years. Think philosophers, scientists, anyone who's ever just looked up at the stars. So let's follow the clues and see what kind of an answer science has managed to piece together so far. So, where does the story start? Well, it begins a long time ago. And when I say long, I mean, get this. Our universe is 13.8 billion years old. Just try to wrap your head around that number for a second. That's the cosmic calendar we're dealing with here, from that very first moment all the way to the incredible universe we see around us today. Okay, section one, a very hot beginning. We're talking about the first 3 minutes of creation. So let's wind that clock all the way back. Now, the universe didn't start with some kind of gentle sunrise. No way. It began as an unimaginably hot, chaotic explosion of pure energy. And that first era, especially those first 3 minutes, they set the stage for literally everything else. And things happened insanely fast. I mean, in a tiny fraction of a second, what we call cosmic inflation, the entire universe ballooned out, expanding by a factor of, well, a number so big it's hard to write down. Then, at just a millionth of a second old, it was this hot, thick quark soup that finally cooled down just enough for protons and neutrons to form. And then boom, by the 3 minute mark, those particles started smashing together, forging the very first atomic nuclei. We're talking the basics, hydrogen and helium. The building blocks were already in place. And you really can't overstate how important those first few minutes were. I love this quote from Professor Joseph Silk, who says, "The essence of life as we know it was produced in the first 3 minutes after the beginning of the universe." Think about that. The fundamental stuff that makes up you, me, the planet, everything, it was all cooked up in that primordial fire, right at the dawn of time. The seeds for everything were planted right then and there. So up next, we have the first light and how we finally ended the cosmic dark ages. Because after that initial, absolute frenzy of creation, the universe kind of went quiet for a long time. We're talking hundreds of thousands of years with no stars, no galaxies, just a hot, dark fog of particles. This was the era of the cosmic dark ages, like a long cosmic pause before the real show could begin. For about 370,000 years, the entire cosmos was basically an opaque, superheated fog. It was so hot and so dense that light was just trapped, bouncing around like a pinball. You literally couldn't see through it. But as the universe kept expanding and cooling down, it hit a critical point. Electrons were finally able to latch onto nuclei, forming the first stable neutral atoms. This moment, which we call recombination, was huge. It set all that trapped light free in one brilliant flash. And for the very first time, the universe became transparent. Okay, so how do you go from a smooth, see-through universe to one packed with stars and galaxies? Well, it was a step-by-step cosmic construction project. First, you start with these teeny tiny ripples in space left over from that initial inflation. Those were the seeds. Then, gravity starts doing its thing, pulling on this invisible stuff, dark matter, and gathering it into these massive clumps, or halos. These dark matter halos became like gravitational anchors. They started pulling in all that hydrogen gas from the Big Bang until the gas got so dense and hot that ignition. The very first stars lit up. And the most amazing part, this isn't just a theory we cooked up anymore. This is something we can see. Thanks to the incredible James Webb Space Telescope, we now have actual pictures of these baby galaxies being born. We're literally looking back in time over 13 billion years to witness the cosmic dawn. It's just mind-blowing. Next up, the invisible scaffolding. This gets into the mystery of dark matter. Because yeah, I just mentioned a really important ingredient in that recipe for making galaxies, dark matter. And it turns out all the stuff we can see, the stars, the galaxies, us, it's just the tip of the iceberg. It's all built on top of this enormous invisible framework. And here's what that framework looks like in a simulation. We call it the cosmic web. You can see these bright clustered spots. That's where the galaxies are, where the visible matter is. But connecting everything, all those long spidery filaments,
That's the dark matter. It is the invisible scaffolding of the universe, and its gravity is the engine that pulled all the visible stuff into the amazing structures we see today.
So, what exactly is dark matter? Well, that's the billion-dollar question. We know it's some kind of mysterious stuff that we just can't see. It doesn't give off light, it doesn't block light, it does nothing with light. And yet, get this, it is the heavyweight champion of the universe. It makes up a whopping 85% of all the matter in the cosmos. Its gravity is the only reason galaxies could form. Bottom line, no dark matter, no galaxies. Simple as that.
Let's move on to our next section, the runaway expansion, which is all about the shocking discovery of dark energy. See, for most of the last century, scientists thought they had the basic story figured out. The universe is expanding from the Big Bang, sure, but the gravity from all the galaxies is acting like a brake, slowing it all down. Makes sense, right? Well, in the late 1990s, they found something that just flipped the entire script. I mean, it's just common sense, isn't it? If you throw a ball up in the air, gravity makes it slow down and come back. The Big Bang was the ultimate throw, pushing all the galaxies outward. So you'd think the combined gravity of, well, everything would be slowing that expansion down. That's what literally every single astronomer on the planet expected to find. But they found the complete opposite. It's right here in this source from the NIH. They call it the astonishing result. They discovered that the expansion of the universe isn't slowing down one bit. In fact, it's speeding up. For the last 6 billion years or so, something has been hitting the gas pedal, pushing everything apart faster and faster. And when they started to crunch the numbers to figure out why, the picture of our universe got even weirder. Just look at this breakdown of, well, everything. All the normal stuff, the stars, the planets, you and me, that makes up less than 5% of the universe. 5%. The rest of it, about 23%, is that dark matter we talked about, and a mind-blowing 73% is this mysterious dark energy, the stuff that's causing this runaway expansion. It's just wild. So what is dark energy? The honest answer is we have no idea. The leading theory is that it's some kind of energy that's just built into the fabric of space itself. You can think of it like an anti-gravity force. So you've got this cosmic tug of war. Dark matter's gravity is trying to pull everything together, and dark energy is trying to push everything apart. And as of right now, dark energy is winning. Okay, our final section. What happens in the end? Looking at the ultimate fate of the universe. Because really, this all leads to one massive question. If this dark energy stuff is pushing everything apart, and it's getting faster and faster, where does it all end? What's the final page in the story of everything? As it stands, science has two main theories about how it could all end. The first one is pretty violent. It's called the Big Rip. The idea here is that dark energy just keeps getting stronger and stronger until its push is so powerful it overcomes everything. It would literally rip apart galaxies, then tear solar systems apart, then planets, and eventually even the atoms that make up you and me. The other option is a little less dramatic, but maybe more unsettling. It's called heat death. In this version, the universe just keeps expanding and cooling and getting emptier forever, until one day the very last star flickers out, and everything just fades into a cold, dark, silent void. You know, it's pretty humbling when you think about these enormous timescales. And what's really cool is how our modern science sometimes circles back to ideas from ancient philosophy. St. Augustine once wrote, "There can be no doubt that the world was not created in time, but with time." He was basically saying you can't ask what happened before the beginning because time itself was created in that moment. And that's a puzzle that cosmologists are still wrestling with today. So, from that tiny, hot, dense beginning all the way to this massive runaway universe we find ourselves in today, we've managed to piece together a truly incredible story of our origins. But as we've seen, huge mysteries like dark matter and dark energy prove that this story is nowhere near finished. We're still discovering new chapters. And that ongoing quest to figure out where we all came from leaves us with the most exciting question of all. What are we going to discover next?